In this video, I'm going to be demonstrating how to assemble one of these hyperspectral open source images, HOSI for short. So first off, make sure you have all the 3D printed parts, and for assembly you will also need some of these nuts and bolts. These are M3 standard, so here they are, that is 3mm. You'll need 3 that are these are 6mm long ones, and you will need 6 that are 10mm long. Then you also need these square nuts. These are standard thin square nuts, so these are only 1.7mm thick. And these all slot into the 3D printed parts to allow you to assemble everything. You'll also need the lens. So this is a silica quartz lens that I've already placed into this threaded lens holder. And all I've done is put some little blobs of glue to hold it in place. I like using UV curing glue. It's really cheap and it doesn't have any residue like other glue. So you can see I've just put 4 blobs on this side to hold that lens in place, and then this will screw into the assembly and allow for focusing. So of course the important and in a way part of the trickiest job is to do the soldering, and here I can show you a soldered situation. So the first stepper motor can just be soldered directly to the stepper motor control board, and here we've got those the control board. So here we've got the Arduino microprocessor board, and here we've got the two one board for each stepper motor. I've had to take off the header pins here so that I can solder directly to it, and I can squidge them all together to fit them into the housing. You might need to modify the housing if you have different shaped stepper motor boards. Then all I've done is stack them. So I use blue tack to stack them together so that they don't contact each other, and which would be bad. When you're soldering these things together, you need to remember that this stepper motor can just be soldered directly, but this second stepper motor, you need the wires connecting it to the control board to go through this 3D printed part, because it needs to go through this hole. The stepper motor, annoyingly, I've made the hole slightly too small to fit the motor through, so you need to solder that into position. You also, of course, have to have the spectrometer itself, the Hamamatsu microspectrometer. This does fit through the hole here, though, so you don't need to worry about the order in which you solder these things together. For soldering, I have used this enameled copper wire. It's very thin and it allows it to be very flexible because the motors are panning and tilting, so we need a wire that's nice and flexible and also therefore very thin. I've used this enameled copper wire, which is only about 0.25mm thick. If you haven't soldered with enameled wire before, it's basically like normal wire. It's copper wire with a thin glass coating that insulates it. So it is insulated wire. It's not bare copper here. And you just need to, the end that you're preparing to solder, just scrape a little bit of the enameling off. Or if you're using a very hot soldering iron, the enamel will melt off on its own. And then just solder as usual. It's actually, once you get the hang of it, really nice and easy to use. And then I've just twisted them together to make a thread like this. So one going to the spectrometer, and another bundle of enamel threads going to this. So this is the tilting spectrometer that controls the up-down axis of the system. So I've had to replace the wires that originally come with the stepper motor and replace them with these thinner ones so that I can do it. You could just imagine if you had that many wires of this original thickness going through, there just wouldn't be space. So this stepper motor, you can leave the original wires. This you need to replace with nice thin wire of some kind. You could use ribbon as well, of course, but it can be a bit tricky to use. Okay, so just follow the wiring diagram. The soldering should be fairly straightforward. with everything soldered together, we just need to put everything into the housing. And I've made the housing very small, slightly awkwardly small perhaps, but it means that the whole unit is very small. So the stepper motor control boards, at least the versions I have, they fit into here underneath snugly. There we go. And then the Arduino microprocessor. So I've got these blobs of blue tack between all these boards to keep them separated from one another. This Arduino, the USB port slots into here, that hole there. And once you do that, it all just kind of holds in place, like so. Then this stepper motor is arranged like this. You'll notice that the holes of the stepper motor align with the holes of the housing. We're keeping all the wires nice and out of the way, going around the back, so that if I show you from the top, there's not much sticking through from the top. We need to make sure that these wires aren't in the way, because we're going to be putting the housing through to lock this system together. Here we have the base of the case. There's a thread screw for tripod attachment, and we've got these sections here that are doing all sorts of different things. So first we need to, you'll notice that there are slots in these pillars. You need to just take one of these thin nuts and put one in each one. They just slot in like so. And then when the bolt goes through, it tightens against that. And we take this assembly and we put it together like so. Now we can take one of these 10mm bolts . And that locks together the assembly casing and the motor all in one go. There's a second bolt to hold this assembly together, and if you'll notice here, there's another slot. We can just pop in one of these nuts, insert another 10mm bolt. That's the base assembled. Next we have the assembly here for panning. So this is the assembly that holds the motor and the spectrometer together. You can see here I have looped this wire around in this hole here. You probably don't need to loop it, just attach it in some way. And the motor just attaches here like so. You'll see that there is a sort of cutout in the model for just putting a nut like so. And for this one we use one of the shorter, the 6mm bolts. Underneath this assembly, you'll also see a space for a nut, a nice slot for a nut here, and a hole through that we use one of the longer bolts, one of the 10mm bolts through here. And this allows us to tighten this assembly onto the stepper motor below. So I'll just very loosely do it for now. And it's good to loop the cables. So these cables are going to be flexing. Every time the spectrometer turns left and right, we need these cables to flex with it. So I've just looped them around the axis of this motor once. You'll see there's a nice bit of space down there. There's a slot on the bottom here that just slots onto, like so. Once that's done, we can just tighten this nut fully this bolt against the nut fully, and that will lock this assembly together. So it's just locking it onto that stepper motor below. Okay, so now we have a setup like this. We have the pan and the tilt motor attached. Now we need to have the assembly to put the spectrometer inside. Now we've got this tilting mechanism to assemble and put on. The first thing we need to do though is loop this spectrometer wire around this motor axis. Just give it one loop around it, like so, and then leave it to the side. You may also find that when you go to put this assembly on, there's not space. This cutout here, this slot in the 3D printed base, that side goes onto the shaft of the motor here, like so. If you find there's not enough space to do this, what you can do is loosen these two nuts of the motor, and there's enough play to just raise this motor up very slightly. This will let you put this assembly on like so. But before we do that, we need to make sure we've got all the nuts in position. So let's start with this one at the bottom first. You need to put one nut in here, one of these square nuts, and put the assembly underneath like so. Then you'll notice there are gaps in the side to put a nut in here, and another one in here. Make sure they are aligned, bedded right in nicely. Then the top bit just slots on top like so. And we need a 10mm bolt in each of these holes. The square nut that we put on this hinge here, that turns this bolt into the pivot point. What you need to do is make sure that the 3D printed part here allows the head of this bolt in, and for it to rotate really nice and smoothly without too much play. Generally, when you 3D print it, it won't quite fit in neatly, so either sand it down until it works. An easier method though is to heat up this bolt over a flame, blowtorch or so on, just so it's hot enough to melt the plastic very gently, and put it in so that it is flush, this outside is flush with the plastic there. And then when you pull it out, it will leave a nice bed in the plastic here that's a perfect fit, and that will reduce play. So then we just put this is a 6mm nut, the final one, into here, and it tightens against that nut that we've already positioned. Doesn't need to be too tight, and this means that we have a nice head, and there's no movement in this system. The only play in the whole system comes from the stepper motor gearing system. Finally, we can put the spectrometer into its bedding hole here. I find it just slots in and stays there. You don't have to really do anything else. It doesn't need gluing in or anything. Of course, you can glue it if you want. I've also cut a tiny piece of rubber that I put here, that's just the right kind of size to wedge all of these wires into this little channel, the little channel here, like so. Now we can check that there's enough play in the cables that it can look all the way up and all the way down, and that these wires are coiling in the corner nicely. And likewise, the wires underneath here, they should allow movement in all these directions, because it needs to be able to move 360 degrees. So these wires need a lot of flexibility in them. So the final part of the assembly is simply to put the lens into position. Here's the lens. I mentioned earlier how to glue it into position, embed it into this threaded 3D component. I also made this 3D printed part which you can use to thread the lens into the housing, and you can write on this where the lens needs to be to focus at different depths. So basically this just needs threading into here. This is where you find out how good your 3D print is, because 3D printers are not necessarily always the best at threading. Then this part has these notches here which fit with the part here, and I just need to screw it in. And I know that I've written inf here, infinity, so that as I screw it in, when I reach that infinity point, this system will be focused on infinity. This might be different for your precise setup. There we go. So now that that notch is aligned with that point, that's where I've decided infinity is, where I've pre-measured it is. As you can see here, I've got other distances which allow me to focus at different positions. So here we go. That's the final assembled setup. Once you have completely assembled your kit, there's just a few things to double check are working first. First, that this rotational thing can happen nice and smoothly, so that this tilt mechanism can move in its housing as snugly as possible. What you need to do is make sure that this section here is as close as possible without grinding against itself. So you can adjust the location of the motor with these nuts and bolts here, loosen these to move the motor up and down so that this can rotate freely but as close as possible to that housing. This is important because when it takes the dark measurement, it rotates the lens down into the housing here for the dark measurement to be taken. So if there's too much light leaking around, if there's too much of a gap there, that won't work very well. Also, just check that generally there's everything can rotate freely, that there's good movement in all the mechanisms, and that you can access the USB port, that the wires aren't grinding against one another, getting in each other's way, and so on. Then you should also be aware that the default start location for this system is sort of as shown here. The tilt mechanism needs to be facing completely down for its dark measurement. This is the starting point, and this should be facing forward. And whenever you turn on the system, it should be in this position, and it should go back to this position at the end. If anything goes wrong, if you have to stop it halfway, just turn it off. You can just manually move it back into this position. Okay, there we have it.